This is question 35 of Civil Engineering paper K 2015 forenoon session. A tapered circular rod of diameter varying from 20 mm to 10 mm is connected to another uniform circular rod of diameter 10 mm as shown in the following figure. Both bars are made of same material with the modulus of elasticity E is equal to 2 into 10 to the power 5 megapascal. When subjected to a load P is equal to 30 pi kilonewton, the deflection at point A is. So in this question, two rods are given. The first rod are tapered in nature and the second rod is uniform in diameter. And both the rods are connected to each other. And a force of 30 pi kilonewton is acting at bottom of the rod as depicted in this figure. Now we need to find the deflection at point A. So this question is from the topic of stress strain characteristics. You may study about this topic in detail by watching lecture 8 analysis of strength of materials by Professor Sriman Kumar Bhattacharya, IIT Kharagpur. So in this question we need to find the deflection at point A. So the deflection at point A is due to deflection in bottom rod and deflection in the top rod. So suppose this is point A, this is B, and if this is C, so deflection at point A will be due to deflection at portion AB or bottom rod plus deflection due to portion BC, that is tapered rod, due to tapered rod. So first we find the deflection in AB, in portion AB, that is uniform rod. So we know the deflection due to load is can be found by the formula PL by AE, where P is the load, L is the length of the rod, A is the cross section area, and A is the modulus of elasticity. So here P is given as 30 pi kilonewton. So in Newton it will be 10 to the power 3. Length is 1.5 meter. So since this is in meter and diameter is in millimeter and load is in kilonewton, and also we need to answer in mm. So that's why just convert all the unit in mm. So length is 1.5 mm, so it will be 1.5 meter, so this will be 1500 mm length divided by area. So area pi by 4 into diameter squared, so diameter is 10, so 10 square into modulus of elasticity, which is given as 2 into 10 to the power 5 megapascal. Now when we solve this, we will get the deflection as 9 mm. Now find the deflection in portion BC, that is in tapered rod. So in tapered rod, the deflection can be found the formula 4PL by pi into D1 into D2 into E, where D1 is the cross section at one point and D2 is the cross section at the last point or another point. So 4 into P is the same, that is 30 pi into 10 to the power 3 Newton. Length of the tapered rod is 2 meter, that is 2000 millimeter, 2000 divided by pi into D1. So D1 is 20 mm and D2 is 10 mm. So 10 mm into E is 2 into 10 to the power 5 given in the question. So when we solve this, we will get this deflection as 6 mm. So now the deflection at point A is due to deflection in bottom rod and plus deflection in top rod. So deflection in AB we found 9 mm and deflection in BC we found 6 mm. So that is 9 plus 6, that is 15 mm. So we got the deflection at point A as 15 mm. So the deflection at point A is 15 mm. So 15 is the correct answer for this question. Thank you.